I'm Anil Kumar. Here is a probability question related to the game of cards. What is the probability that a three-card hand contains a pair? Now, when we say pair, what we're trying to say here is we have a three-card game. So same of one type. We call them as denominations. So we have two of same denomination. So in a game of cards, you have four of each kinds, and what you really have is you have ace, right? You have king. Let me write. Then really use symbols: queen, jack, and the numbers 2, 3, 4, 5, 6, 7, 8, 9, and 10, and all are of four different suits, right? Hearts, clubs, diamonds, and spades. So that makes 52 cards, right? So 13 times 4 makes 52 cards. Now the question is, what is the probability that a three-card hand contains a pair? That means two aces, two kings, two twos, two fives, something like this. So when we have two of same kind, the third one is of a different kind, right? That's important to find. Okay, so that's important to consider. Okay, now let's see how to do it. Steps involved will be, first, we have to select one denomination, right? So first step in this case is to choose a denomination, right? Choose a denomination. It could be any one of these, right? So it is a choice which will be out of 13, we have to select one. So this is 13C1, right? Now these three cards, when we place, order does not matter, right? So order does not matter. Since order does not matter, it is a case of combination. Let me write down here. We are working with combination in this example since order does not matter, right? So order is not important. Now, the pair could be in any place. It doesn't really matter. Okay. Now, once we have selected that this is what we need, okay, then we have to get two of that kind, right? So we have to get two of same denomination, right? Or I should say that denomination. So for each denomination we have four. So that is to say we are selecting or we are choosing out of four two cards, right? So once we get two cards, the third one could be any other, right? So once we have selected these two cards, the third card is, so we say third card is different denomination. So that means we have 52 cards in all, right? We have 52 cards. So 52 take away 4, we are left with 48 cards. Is that okay? So we are left with 48 cards. So it could be any one of these 48. So that is 48C1. Got it, right? So that is what it is. So these are the total ways of getting a pair in a three-card hand, right? So we say, so the number of ways that the event A, which is getting, we'll call this as an event A, is 4C2 times 48C1. Oh, I forgot to write 13C1. Let me write it now. 13C1. So product of these three will give us the number of ways we can get a pair, right? So this is total number of ways. As far as total number of combinations is, we have 52 cards and we are taking 3, right? So that becomes the combination. And therefore, the probability which is for getting a pair will be ratio of these two, right? Ratio of these two. Correct. So let's find the ratio. So we can write this as 4C2 times 48C1 times 13C1 divided by 52C3, right? So we can use the calculator, find the answer. So that's how we can do it, right? So it is 4C 2 times 48 C1 times 13 C1, which is equal to 3744 divided by, so first we'll just find what is 52 C3 is, right, and that is 22,100, and then we'll do the division. 3744 divided by 22,100, and that is 72 over 425. Okay, so that is a simplified form in fractions. So that is the probability of getting a pair in a three-card hand. I'm Anil Kumar, and I hope you understand and appreciate the steps which we have taken to find the correct answer. Thank you and all the best.